Dear students, now we are going to discuss direct broadcast satellite in detail. It is also called as DBS. So this direct broadcast satellite is a geostationary satellite which can be widely used to transmit radio and TV programs. So it is mainly used to provide broadcast transmissions to cover the large areas of the earth. So and also to provide the direct transmission into the home, simply known as DTH, direct to home. Okay, that is also known as broadcast service. So here the broadcast services are audio services, that is radio signals, TV and internet services. This DBS TV is nothing but the digital TV system. So this is the overall picture of this DBS system. In this one, the network service provider is going to broadcast the signal using this DBS system. So here teleport is the ground station which can connect the signal from this network provider to the satellite. Okay, so here the direct broadcast satellite is going to transmit the signal directly into the end user's home or to the cable network. So this is called as DTH service, direct to home service. So in this one we can consider two parts. One is outdoor unit, another one is indoor unit. So in this system the uplink frequency range is 17.3 to 17.8 GHz. The downlink frequency range is 12.2 to 12.7 GHz. Okay. So in this lecture video, we are going to cover these two important topics. One is home receiver unit. The next one is parameters used in this direct broadcast satellite. So here home receiver consists of two units. One is indoor unit, the next one is outdoor unit. The parameters of DBS systems are orbital spacing, number of transponders, frequencies and polarization, bitrate, forward error correction, MBEC compression standards. Okay, let's start with this home receiver unit. It consists of two units, outdoor unit and indoor unit. So in this outdoor unit, we are having the parabolic reflector, that is nothing but the dish antenna. Okay, so it can be used to receive the downlink signal and then feed the signal to this horn. Okay, so here it is a parabolic reflector. The downlink signal frequency is 12.2 to 12.7 GHz. Okay, so here the horn feeds the signal into the polarizer. So in this satellite system, we can have two kinds of polarization. One is left hand circular polarization, another one is right hand circular polarization, especially for TV signals. Okay, so we have to select a particular polarization at this point. Then that can be given to this low noise block. So it performs two important operations. One is low noise amplification, another one is down conversion. So noise amplification means it is going to amplify the satellite signal without degrading the signal to noise ratio. It is only going to amplify the signal strength. Okay, so without degrading the signal to noise ratio, that is the important function of this low noise amplifier. Then the amplified signal is down converted from this 12.2 to 12.7 GHz to 950 to 1450 MHz. So this is the suitable range for indoor unit. Do you all understand this one? Actually we are receiving the signal in 12.12 to 12.7 GHz, but indoor unit can support only in the range of 950 to 1450 MHz. So this down conversion is very important. So this down converted signal is given to this indoor unit as input. Do you all understand this concept? So the parabolic reflector antenna is used to focus the downlink signal into the receive horn antenna. The horn feeds the signal to the polarizer. There are two kinds of polarized signals used. Left hand circular polarized signal, right hand circular polarized signal, especially for TV signals. Okay, So we can identify which type of signal is getting received. Based on that, we can give the polarized output. Then the low noise block, it consists of two parts. One is low noise amplifier, the next one is down converter. Low noise amplifier is used to amplify the satellite signal without significantly degrading its signal to noise ratio. Here down conversion, it is a very important part to convert the CRQ band to L band. So L band is suited for indoor unit operation. So here the 950 to 1450 MHz is the suitable frequency range for connecting the cable into indoor unit. Here the antenna size is about 18 inch, that is 46 centimeter in diameter. That is the size of our dish antenna. Okay. Here the reduction in gain due to the scattering effect. So since there may be some scattering effect from this parabolic reflector, that can be identified as eta RMS is equal to e power 8.8 sigma by lambda. Here sigma is nothing but RMS tolerance for that particular dish TV. Okay. Lambda is the wavelength. So next we are going to discuss the indoor unit. So in this one, we are receiving the signal from satellite, that is the downlink signal in the range of C band or Q band. So that can be down converted into the L band range, so which is suitable for indoor unit. Okay. So here in this indoor unit, the very first block is tuner block, which is going to select the particular transponder. Because in the satellite, we can say in the satellite there may be 32 transponders, each one is having particular TV programs. So here satellite is having 32 transponders. So each transponder is having its own TV channels. Okay. So here the tuner is going to identify or select the desired transponder. If I am using Sun Direct, I can select that particular transponder. If I am using Tata Sky, I am going to select that particular transponder. You all understand this one. So tuner is going to select the particular transponder for which we are receiving the service. Okay. Then that particular signal is given to this demodulator. This demodulator is going to demodulate the carrier signal. Actually, in this satellite system, we are going to send the QPSK modulated signal. The receiver side, this QPSK modulation is converted into the bit stream. Okay, so here we are using the demodulator block to convert the received modulated signal into the bit stream. So whenever we are talking about bit stream, so here there may be some bit errors. Correct. That can be rectified by using this FEC. FEC means forward error correction. So next one is stream demultiplexer. So in this one, a single transponder can transmit a multiple signal as a single TDM signal. So here we are using TDM signal. That means all the signals like analog TV signal, radio signal, data signal, video signals can be multiplexed as a TDM signal. So that can be demultiplex at this point. Okay, demultiplex means if there are 8 channels, then all the 8 channels are separated at this point. Okay, using this demultiplexer, that can be given to that audio block and video block as a separate one. So here this can be controlled by this microprocessor and controller in the indoor unit, which is going to control the tuner to select the particular transponder, the stream demultiplexer to demultiplex the TDM signal into the proper range, and then control all the access through this. Do you all understand this one? So conditional access is nothing but PPV, that is pay per view. That means we need to pay certain subscription amount for each channel, right? So for that we can get the conditional access through this microprocessor and controller memories in the indoor unit. So these all are very important parts in this indoor unit. So here indoor unit must be able to receive any one of the 32 transponders a satellite can bring 32 transponders within it. Okay. So of this 32, 16 may be LHCP signals, that is left hand circular polarized signals. The remaining are right hand circular polarized signal. So this can be identified by the polarizer in the outdoor unit. Okay. The received signal is QPSK modulated signal, which may consist of 4 to 8 TV programs as time division multiplexed signal. The tuner is used to select the desired transponder. Then the carrier is demodulated, that is, the QPSK modulated signal is converted into a bit stream. So while converting the modulated signal into a bit stream, the errors may be occurred. Correct? So here the forward error control block is used to control the errors in data transmission. So next, the demultiplexer is used to separate the individual programs which are stored in the buffer storage. After that, the conditional access, that means pay per view, is used to select a particular program because each channel subscription is mandatory. Okay, and then the connection through a modem can be applied for further processing. So next, downlink analysis for this DBS. So here we are mainly concentrating on the ratio dB to NO, that is bit energy to the noise density. Its value is at least 6 dB. Its marginal value is 4.3 dB under clear sky condition. So similarly, we have to concentrate on the uplink also. So in this uplink side, ground stations like teleport provide the uplink signal to the satellite. This uplink signal is a complex signal because it is a combination of various sources like video signal, data signal, analog TV, radio signal, etc. So all must be converted into a uniform digital compressed and TDM signal. So this uplink is very important part. Okay.